Hello and welcome to Algebra 1 Test Section 1 on equations of a line. All right, so we want to write the slope-intercept form of the equation of each line given the slope and y-intercept. So to start out, we're given a slope m that's equal to -2/5 and a y-intercept that occurs at 0, -2. So our slope-intercept form looks like this. It's y equals m the slope times x plus b, where b is going to be the y value for your y-intercept. So this is b. So if I was to write this, all I need to do is plug into the formula, right? I would have y equals, for m, I'd plug in a -2/5, then times x, and then where I have plus b, I could write plus -2, or of course I could write -2. So this would be in slope-intercept form. Y equals -2/5 x minus 2. All right, for the next one, I'm given a slope m that's equal to 3/4, and now a y-intercept that's at 0, 1. So again, we have y equals mx plus b. So m is the slope. That's the slope. And then b is going to be 1. All right, that's the y value for your y-intercept, right? It occurs at 0, 1. Let me make that a little clearer. So we would have y equals, for m, I'd plug in 3/4 times x and then plus b. So b is 1, so plus 1. So y equals 3/4 x plus 1. Hello and welcome to Algebra 1 Test Section 2 on equations of a line. So we want to write the slope-intercept form of the equation of each line given the slope and y-intercept. So the first one here, we have that m, which is our slope, is equal to -5/4, and the y-intercept is going to occur at 0, 3. So the generic formula for slope-intercept form is y equals m the slope times x plus b the y-intercept. So this is the slope, and this is your y-intercept. Right, so in this case, m is -5/4, and b is 3. So we just have to plug in. Right, so y is equal to, again, the slope is -5/4. That represents m here, times x, and then plus b, so plus 3. That's the value for y in the y-intercept, right? So the y-intercept occurs at 0, 3. So 3 is going to get plugged in for b. So y equals -5/4 x plus 3. All right, so now we have a slope m that's equal to -6, and a y-intercept that occurs at 0, 5. So again, y equals mx plus b. I'm going to plug in for m. I'm going to plug in a -6. I'm going to plug in for b. I'm going to plug in a 5. So y equals -6x plus 5. Hello and welcome to Algebra 1 Test Section 3 on equations of a line. All right, so we want to graph each line. We're going to start out with y equals -2x plus 4. So this is given to us in what is known as slope-intercept form. So slope-intercept form is y equals m the slope times x plus b the y-intercept. So if I have an equation in this form, I immediately know two things. I know the slope, and I know a point on the line, which is the y-intercept. So the slope here, m, is equal to -2, right? It's the coefficient of x. And the y-intercept is going to occur at 0, 4. So let's go down and graph this. So again, the point I know is 0, 4, and my slope is -2. So m equals -2. And in terms of us graphing things, we like to write this as rise over run. So I'll write -2 as -2 over 1. So the first thing we're going to do is we're going to plot this point 0, 4, right, the y-intercept. So I'm going to go up here, plot that point, and then I'm going to get some additional points using the slope. So the rise is -2, so that means I fall 2, 1, 2. My run is 1, so that means I go to the right 1. So here's another point. Fall 2, 1, 2, to the right 1. There's another point. Fall 2, 1, 2, to the right 1. There's another point. And you can keep going, or you could change this up and say, okay, well, -2 over 1 is the same thing as 2 over -1. So I could have started here and I could go up 2, 1, 2, I'd rise 2, and then go to the left 1. right? Because a run of -1 means I go to the left one. So here's another point. And then once you have enough points, really you only need 2 or 3, you can just draw a line. Okay, so again, this is the graph of y equals -2x plus 4. All right, let's take a look at y equals 4/5 x plus 1. So again, I'm given the slope. This is your slope. This is m. I'm given the y-intercept. The y-intercept is going to occur at 0, 1. I can go down to my graph. I know a point on the line. It's 0, 1. And I know the slope, m, is, again, 4/5. So I'm going to write this as rise over run to make it easy for us. So this is 4 over 5. I'm going to start at that point 0, 1. So that's right here. I'm going to rise 4. 1, 2, 3, 4. I'm going to run 5. 1, 2, 3, 4, 5. I'm going to, again, rise 4. 1, 2, 3, 4. Run 5. 1, 2, 3, 4, 5. And if I want some points over here, I can kind of write this as -4 over -5. Right? It's negative over negative is still positive. So I would fall 4. 1, 2, 3, 4. And I would go to the left 5. 1, 2, 3, 4, and 5. So that point's on the line as well. And make that a little better. Now I can graph the line. Okay. And we'll connect that with some arrows. And let me kind of make that a little cleaner. Okay. So this is the graph of y equals 4/5 x plus 1. Hello and welcome to Algebra 1 Test Section 4 on equations of a line. All right, so we want to write each using point-slope form, then solve for y and place the equation in slope-intercept form. All right, so for the first problem, we have a line that goes through the point -5, 3 and has a slope that's 2. So for the point-slope formula, we have y minus y sub 1 is equal to m times the quantity x minus x sub 1. Okay, so this given point here, we label this as x sub 1, y sub 1. So I'm going to plug into the point-slope formula. So for y sub 1, I'm going to plug in a 3. For m, I'm going to plug in a 2. And for x sub 1, I'm going to plug in a -5. So I'd have y minus 3 is equal to 2 times the quantity x minus a -5, which is the same as x plus 5. So this right here is called point-slope form. So if you're asked for that on a test, that's where you could stop, right? This is the point-slope form. But we're asked to go further and put this in slope-intercept form, which means we want to solve for y, right? We want y on one side of the equation by itself. So to do that, let's simplify. Let's go y minus 3 is equal to 2 times x, that's 2x, plus 2 times 5, that's 10. I would add 3 to both sides of the equation, and I would have y is equal to 2x plus 13. So this is slope-intercept form. And again, this mirrors y equals mx plus b, where m is your slope, right? That's the coefficient of x, and b is your y-intercept. In this case, that's going to occur at 0, 13. So for the next one, the line goes through the point -1, 2, and the slope m is -3. Again, the point-slope formula is y minus y sub 1 is equal to m times the quantity x minus x sub 1. All right, so I'm going to plug in for y sub 1, for m, and for x sub 1. So again, I'm going to label this point as x sub 1, y sub 1, and just plug in. So for y sub 1, I'm plugging in a 2. For m, I'm plugging in a -3. For x sub 1, I'm plugging in a -1. So we'd have y minus 2 is equal to -3 times the quantity x minus a -1, which is the same thing as x plus 1. So this is point-slope form. And again, we want to continue until we get it in a slope-intercept form. So I'm going to keep simplifying. So y minus 2 is equal to -3 times x is -3x. And then -3 times 1 would be -3. So now I can just add 2 to both sides of the equation. That's gone. I'll have y is equal to -3x. -3 plus 2 is -1. So y equals -3x minus 1. And again, this is slope-intercept form. We have y equals mx plus b. right? Where -3 is the slope, m, and -1 is your b, your y-intercept. All right, so now we have a line that passes through two given points, but we're not given the slope. So through 0, -5 and 5, 2. So in this situation, we have to use our old-fashioned slope formula to calculate a slope. So then we can use either point and the slope that we just got to put it in point slope form. And then we can then solve for y and get it in slope intercept form. So I'm going to label this as x sub 1, y sub 1. And this is x sub 2, y sub 2. And my slope formula, as you'll remember, m, the slope, is equal to y sub 2, which is 2, minus y sub 1, which is -5, minus the -5 is +5, over x sub 2, which is 5, minus x sub 1, which is 0. So 2 plus 5 is 7, over 5 minus 0, which is 5. So my slope m is 7/5. Now, here comes the tricky part that nobody gets. Once you've used these 2 points to calculate the slope, you only need one of them. And it does not matter which one it is. You can pick this one and forget about this one, or you can pick this one and forget. It doesn't matter. Just get rid of one of them in your head. So I'm going to erase everything and just say, okay, this right here is going to be my point. X sub 1, y sub 1. You don't need to worry about this. No matter which point you end up choosing, it works. In the end, when you solve for y, you get the same thing. Okay, and I've demonstrated that before in previous videos. So what we're going to do now is we have our slope and we have a given point. We're going to plug it into the point slope form. So we have y minus y sub 1 is equal to m times the quantity x minus x sub 1. All right, so for y sub 1, we have a 2 that we're going to plug in. For x sub 1, we have a 5 that we're going to plug in. And for m, we have a 7/5 that we're going to plug in. Okay, so y minus 2 is equal to m, which is 7/5, times the quantity x minus 5. So now, this is in point slope form. Again, if we solve for y, it's going to be in slope intercept form. So we'd have y minus 2 is equal to 7/5 x minus 7/5 times 5. The 5s would cancel and you just have 7. So to solve for y, I just add 2 to both sides of the equation. That's gone, and I'll have y is equal to 7/5 x minus 5. Hello and welcome to Algebra 1 Test Section 5 on equations of a line. All right, so we want to write the standard form of the equation of the line. And the definition I'm going to use of standard form is going to be where we have ax plus by equals c, where a, b, and c are all integers, and a is greater than or equal to 0, and then a and b are not both 0 at the same time. Okay, so let's go ahead and look at what we're given here. We have that y equals -7/3 x plus 1. So the first thing is I want my ax plus by on the left. So I'm just going to add 7/3 x to both sides of the equation. What does that look like? It looks like this. I'm going to have 7/3 x plus y is equal to, this would have canceled, so just 1. Now, the problem I have is that this is a fraction, right? So I want to make this a non-fraction because I'm told that a, b, and c need to be integers. So to do that, I just need to clear this 3. So I can multiply both sides of the equation by 3 to do that. And what am I going to get? 3 times 7/3 is 7. So I'd have 7x plus 3 times y is 3y equals 1 times 3 is just 3. So to put this in standard form, I end up with 7x plus 3y equals 3. All right, let's take a look at another one. We have y equals 1/5 x plus 3. Again, I'm looking for ax plus by equals c, where a, b, and c are integers. A is greater than or equal to 0, and a and b are not both 0 at the same time. So again, the first thing is I'm going to move this term over here. I'm going to subtract 1/5 x away from both sides of the equation. So I'd have -1/5 x plus y is equal to 3. Now there's 2 problems here. This is negative, and I'm saying that a needs to be greater than or equal to 0, so that's a problem. And this is a fraction, and I said this needs to be an integer. So I can do this in 2 steps or 1. So to kind of do it in 2 steps, the first thing I would do is I would multiply both sides of the equation by -1. So let's just do that real quick. So negative times negative would be positive. So I'd have 1/5 x. Negative times positive would be negative. So this would be minus y equals. Positive times negative would be negative. So this would be equals negative 3. So I've solved the problem where this was negative. Right? I just multiplied both sides of the equation by negative 1. The other problem is that this is a fraction. So again, I can just clear the fraction by multiplying both sides of the equation by 5. Right? This denominator here. So what's going to happen is 5 times 1/5 is just 1. Right? So I'd have 1x or just x. Then minus 5 times y is 5y. This equals negative 3 times 5 is negative 15. Now, again, x minus 5y equals negative 15. The quicker way to do that would have been in one step. I could have multiplied by just negative 5 and it would have taken care of both in one step. So again, I wanted to separate it so that you could see what I'm doing, but on your homework or on a test, you want to do it in one step so you can save yourself a little bit of time. All right, let's look at one last problem. We have y equals negative 9/5 x plus 6. Again, I'm looking for ax plus by equals c, where a, b, and c are integers. A is greater than or equal to 0, and a and b are not both 0. All right, so I'm going to start out by adding 9/5 x to both sides of the equation. So we're going to have 9/5 x plus y is equal to 6. The next thing I'm going to do is I'm going to multiply both sides of the equation by 5, right? Because I don't want this to be a fraction. I need an integer. So I'm going to clear that fraction, multiply by 5 over here and over here. So then 5 times 9/5 is just 9, then times x, then plus 5 times y is 5y, and this equals 6 times 5, which is 30. So here's our equation in standard form. We have 9x plus 5y equals 30.